Welcome, Vibito. I'm going to do a little presentation about what public key pinning is and how to implement it, and finally questions. So I like to play a small game. See this logo of Droidcon over here. So just three logo hidden in the slide. Whenever you see the slide with a logo of Droidcon, screen, Android, the first one who do this, a chocolate. Right? Good? Okay, let's get started. So yeah, this is the index about what we're going to talk about. I'm going to talk how it works, what is public key pinning, some demo, and some suggestion about do and don't. Ready for the game? No one? What's that? Okay. I'm Zhao. I studied on UPM in Madrid, and then I did my master in KDH in Stockholm, and then I started working on 2011 different companies, and now I'm working in Visual since 1 year and a half ago. That's my first one in Stockholm as a straight line. So, how does SSL works? How many people here know how SSL works? Can you see? No, very much. Okay, great. So, imagine you receive a SMS like this. You attempt to transfer 950 London's currency. Please contact us on this phone number to verify translation. Please have your user ID and security key to hand. Let's see that we are quite innocent and we see that it's a legal SMS, and we try to call this number. So how can we trust that this is the right number of the bank that we currently have the amount transaction? So what we can do is we call them, hi, are you my bank? And then, yes, I'm your bank, and here's my certificate. What happens next is, okay, I got your certificate, and then I go through the proper authority to see if certificate is valid or not. So imagine our authority say, yes, this is certificate is valid. Then what happens is, okay, the certificate is valid, but doesn't mean that the bank would send me the certificate. It's the owner of the certificate. So someone have to prove that this bank, this entity is the bank itself. So what I can do is count again. Here, the user hide the T-shirt inside box and save it, store it in a place where only the owner of the certificate can get access. And then you ask, what color is the T-shirt? So the bank go to open the box and say the T-shirt is red. So that's some metaphor about how the SSL certificate works. So actually it's a bit more complicated, but process more like that. You get a certificate, and somehow the certificate has a public key. Well, what happens with public key is it's a public. So you cipher some random data, like you hide the red T-shirt inside the box, and then ask the entity who owns the private key to decipher it. What happens, like the cipher process is like go to the secret place and open the box. Only the person who has the private key can open the box. Okay? Got it? Questions so far? No? Okay, great. Yeah? Okay, and what is public key pinning? So, on the web page, you, for example, random.org. When you click on this green icon over here, actually you can see the certificate, and this is how more or less the certificate looks like. Here you have the trusted entity, which is random.org, and this is you have the authority, which who issued this certificate. the public key currently is hiding inside, and it's quite easy to get it. For example, with this command, OpenSSL, on the server you want to indicate port 443, you can ask for the certificate. So if you do this, it's the command, you get the certificate where I set the strings. Okay? This is, sorry, public key with set of strings. And this works with any web page which has SSL in it. The concept behind the public key pinning is basically get that strings and have it saved in your applications. So whenever you connect as entity which has this certificate, for example, a bank application which connect to the server of the bank, because it only connects to this server. So whenever it connects, it gets the certificates and also the public key from the server. And with that, what happens is you compare the public key that you are actually getting from the bank with the public key you already have is saved in your application. But by doing this kind of string comparison, you actually can see if the public key is the server you are connecting, is the owner of the certificate that you expect to connect. So how to do this? Anyone who uses volley here? No? No one uses volley? Oh, yeah, volley. So the way to do it in the volley is implement something called full stack. Okay, we create the new trust manager with the public key manager. This is the class we are going to override. With that, we get some context for TLS. Whenever we create the new full stack, we say the context. This is the context we get the software factory, and then whenever we request anything on the with volley, we use this full stack. Just a few lines ago, you don't have to understand anything. Just copy paste and then copy the public key. Here, a bit of complication relies on the public key manager, which contains a public key as a string. Whenever you request a certificate on init, extract the public key and compare. Simple string comparison. Okay, I like to have a demo of it. The demo is hosted here in my GitHub. You can download it and then
I didn't
you.
get that. Please try again.
Try again. Okay, you can have the demo is on my GitHub, download it, and then what you need is request some API from the random.org, and with that, you can run the application. So I'm going to show this. Anyone know what's random.org is? So random.org just basically are services that you can ask for to give you a random string or random number. So imagine in this case I'm using the API to say I want one number between 1 and 1,000. So you can send something to the server, and server will return you a JSON back, which say okay, this is data we need. We have 966. Just no more complication. So what I did is I did a simple app. This app only has one screen, a text view, where you can actually click on the text view. You request the data to the random.org, compare with the public key, and if everything is correct, just print the number on the screen. For example, click on here. 27,751. So the request you want to see so happens over here. So we generate a JSON the same way as we have done in Postman. We receive 27,751, and we say okay, it's valid. We print it out. That's all. It's quite simple. So how does it work? We have basically two classes. We have the main activity, which call this random URL. We say, oh, we want a number between 1 and 10 and 100,000, and then we generate this JSON object, and this is the part I was talking about. So you get as a context, public key, get context areas, and you have to catch the exceptions. And then on the whole stack, you say, okay, if the SSL context was enabled, use as whole stack as this. And then when you request with this whole stack. The public manager contains the public key embedded as it. You use house type HCD, HCA, and SA. What that do is you receive chunk server trusted, and you basically extract the public key by using all these methods, and then you compare. Okay. Or with 64 encoding, you say, is the public key received the same as I have embedded in my app? If you yes, you just say don't do anything. If not, throw exception. Okay. For example, if this is my the public key I get from random org, if I do just change the string, if I remove this, run it. Yes, it's done. Click on here. Receive the some exception, so that's why I draw on this. What happened here is this is the exception is showing. This I wrote received and to wallet connection as a handshake exception. So actually I verified that as a public key that I get is different from the one which I have stored. So I do not connect to the server. There's nothing shown on the screen because the connection was not trusted, was not established. Okay. So if I put the right public key, we happen the same as before. Click on here and we receive the response. That's it. By the way, too much logo here. Sorry. Okay. So far. Okay. So the song and the suggesting about do and don't. You shall do it if you have facing high security risk banking applications. So nowadays there's a lot of applications which just do connect to the server, like Facebook, Twitter, Instagram, which really need to trust the server that you are doing. Because sometimes what you do is you get a token or you do the login, and if the services which do man in the middle, it can generate different SSL. And what happens with that is the server who gets your user and password, and by connecting to the real server, it will turn the real data. But your user and password is already stored. This is especially critical for banking applications. And I think we have a lot of banks here in Dubai, which is quite useful for that. You don't have to do it if you have frequent change on SSL certificate. Which usually is not the case, because SSL certificate is to be issued by the corresponding authorities, and it's not so easy to do it like every certain time. Also, speed of security, like we have a bit performance difference because we have to track the public key each time we connect to the server. So it's a bit time delay, but not too much. Okay. It was quite short session. My questions so far? This is the last slide.
In the public key concept, should we check the public key like always in all the requests in the application or only once, like when we are starting the session?
Body. When you establish the body, what you do is you check every time that you want to connect to some services. So SSL, you do the request, and then as soon as the request finish, you finish. Just next time when you want to request something, you still have to do the SSL connection handshake again. So with that, you really have to do it each time.
Okay.
Talking about Poland, other libraries?
Science,
Poland, other libraries?
I haven't tested on other libraries, so it should be possible because the SSL printing is getting more and more popular now because it's kind of the security that's really managing the application needs. It should be possible on the libraries.
Do you think there is any disadvantages of using this? I know the security issue, but in terms of loading the speed of it.
Well, is there anything which you can maybe advise us in terms of that can make the app a bit buggy slowly, or everything is going to be as it is well? Especially for example, your app two visits have bigger data, bigger images, and so on.
Yeah, SSL printing is we make your application a bit slower, but not too much because you have to extract the public key each time that you do a request. For example, if you do a handle the search on computer, whenever you do a search, it's a request to the backend and you ship the data. So when you do the request, it could be I don't know, a couple of milliseconds slower. It depends on how much you have, but it's not too much. The problem that the SSL printing could have is imagine that you, for some reason, you have to change the SSL certificate because there was someone who faked it or things like that. So as soon as we change it, you have to update or make sure that all the application which was using the SSL printing is updated because they won't be able to connect to your server anymore. And that's a kind of problem that we might have to face because actually depends on the updation rate. It could be higher, but for us it's more or less like 2 weeks whenever everyone is updated. Then we have to really have both servers running for at least 2 weeks and make sure that most of people get updated because otherwise they won't be able to connect.
So basically, the spinning is to avoid the man in the middle lines, isn't it?
Yeah, it prevents man in the middle.
Right. So basically, if not HTTP, if you work on SIP level protocol stack, basically the secure voice over protocol happens. Mostly people go with this thing called ZRT. So where it follows the Diffie-Hellman algorithm. So the problem is the key itself. You know, like the man in the middle attack, the person can get the key and he can again decrypt the information basically. So the Diffie-Hellman algorithm itself is functioning in such a way that even when two people are communicating, especially with the key, the man in the middle can't actually understand what is happening in between. So I don't know like if it is applicable to the HTTP, but on the SIP stack we use ZRTP for doing this with the Diffie-Hellman algorithm.
What is the question? What is the question?
No, I'm just saying like if the same, because you are trying to avoid the same thing like the man in the middle attack with using the pinning, we can use the Diffie-Hellman algorithm which is already proven. I mean, with the other stack basically.
Yeah, for sure, there's also a way to prevent the man in the middle attacks. That's just one of the possible solutions.
And your code uses the first element of the certificate online ISO. And can you show the code?
Which part? class or which class?
Yeah, public key management, and you get the certificate from the RA.
I get this is implements X509 trust manager, and what happened is
Yeah,
okay, want to go deeper?
yeah. Yeah, chain 0.
Yeah.
So is that is guaranteed to be used in the communication with that
All the
public key?
certificates must have a
Yeah,
public key.
my question is that server can send the multiple certificates in the SSL. So you check the first element, but is that guaranteed to use with the communicating the server? So if the second certificate use the communicating server, so
Yeah, I got the point. Like what he's trying to say is there are different certificates like root certificate, intermediate certificate, which the server sends.
So you have more than one certificate
Yeah,
in that
yeah.
case. I don't think that's usually the case. Usually you have one certificate issued by Commodore or by other companies, because certificate is something quite expensive to issue. Usually the company has one certificate per server that you access. In case you have more than one certificate, what you can do is, based on this code, do the same, extract the public key and encode it to strings, and then compare each of them. In case now you have more than one server which you connect, all you can do is just compare it with one of them and then check if and return true or throw an exception with them.
the certificates are sent from this server.
Yeah, yeah. So the certificate what you get is whenever you connect to the port 443 of any server which has a SSL, it gives you the certificate, and what I did is just get a public key from the certificate. So actually if you do this, so you get all the information that's the SSL gives to you. You get beginning of certificates and subject, client CA name, SSL handshake, and others. You can also get this information if you go to Google. Okay, let's go to the button. So this button indicates that has a valid certificate. When you click on here, you can actually view the details, and you can view the certificate. So here's the screen I showed before. You get all the detail about who the certificate was issued, the issuer name, who issued this certificate, all the signatures, public key information, extensions, all the possible information you might need to verify that certificate is valid. So this should be good enough, but we had some kind of cases a few years ago that Commodore, one of the public certificates issuers, were attacked by another company. So there was some certificate generated issued by Commodore for Google or for Facebook. They were like faked. So just in the world, just very few authorities who issue the certificate, because they have to be proved to be very, very secure. If any of them is hacked, really you cannot trust to the SSL anymore. But this doesn't happen in very frequently. The case of Commodore was, I think, the first time that it was happening. That doesn't happen for these 3-4 years. So SSL certificate should be valid. You should trust it, because there's no better way. No questions? I think we still have plenty of time. I will upload my slide to the script, and I'll be maybe linking my Droidcon.